That airplane flying 35,000 feet above you right now, the system knows exactly where it is. That ship in the middle of the ocean, they know its speed and direction. Even that rain cloud heading your way, they've predicted its arrival down to the minute. All of this because of a technology that's over 80 years old, but 90% of people don't understand how it works. It's called radar, and the way it works is smarter and simpler than you think. The problem is, most explanations start with complex physics equations and electromagnetic waves, and that makes it seem impossible to understand. But the truth? Radar uses the same principle you use every single day without even knowing it. In the next 5 minutes, you won't just learn how radar works, you'll understand why it's one of the smartest inventions in history. Let's start from the beginning. Imagine you're standing in a completely dark cave. You can't see anything at all, but you want to know how far away the wall is. What's the simplest thing you could do? Shout. The sound leaves you, hits the wall, and comes back. The echo. If you measure the time from when you shouted to when you heard the echo, you can calculate the distance. Sound travels at 767 miles per hour. If the echo comes back after 1 second, that means the wall is about 560 feet away. Radar does exactly the same thing, but instead of using sound, it uses radio waves. Instead of a dark cave, it's the open sky. And instead of measuring the distance to a wall, you're measuring the distance to an airplane 250 miles away. And the insane part? All of this happens in less than 1/10,000th of a second. So how exactly does it work? To understand radar, you need to know it has 3 main components. First, the transmitter. This is the part that generates radio waves. Think of it like your shout in the cave. But these waves aren't sound. They're electromagnetic waves moving at the speed of light, 186,000 miles per second. These waves are released in very short pulses. Each pulse lasts millionths of a second. Second, the antenna. This directs the waves in a specific direction and also receives the waves that bounce back. In most systems, the same antenna does both jobs. That's why you see antennas at airports or on ships rotating in a circle to cover all directions. Third, the receiver. This picks up the waves that bounced off the target. But here's the problem. The wave that comes back is extremely weak. Imagine throwing a tennis ball at a wall half a mile away, and when it comes back, it has the same trajectory but is a million times weaker. The receiver has to be extremely sensitive to pick up that signal and distinguish it from any interference. And finally, all this information converts into an image on the screen. That green dot you see in war movies, that's the aircraft. But radar doesn't just know where the plane is, it knows much more. How? Radar can tell you 4 critical things. First, distance, range. This is the easiest part. Remember the echo principle? The system measures the time between sending the pulse and receiving it back. If it takes 0.001 seconds, that means the target is about 93 miles away. Second, direction, bearing. The antenna knows exactly which direction it was pointing when it received the return signal. So, if the antenna was pointing northeast, the target is northeast. Third, speed, velocity. This is where it gets genius. When the target is moving toward you, the radio waves compress slightly, like the sound of an ambulance siren getting higher as it approaches. When moving away, they stretch, like the siren getting lower as it leaves. This is called the Doppler effect. It's the same technology police use in speed guns. The radar measures this compression or stretching and calculates exactly how fast the target is moving. Fourth, size and shape. Different objects reflect radio waves differently. A large bomber reflects more waves than a small fighter jet. Modern radars can even identify the type of aircraft based on its radar signature. But here's what most people don't know. Radar has one massive weakness. Radar can't see everything. Stealth aircraft are designed with special shapes and materials that absorb or deflect radio waves, making them nearly invisible to radar. Objects flying very low close to the ground can blend with buildings and terrain, creating what's called ground clutter. Heavy rain and storms can actually block or confuse radar signals, but military and aviation systems now use multiple radar types. Phased array radars that scan without moving parts, multiple frequencies to penetrate weather, computer algorithms to filter out false signals, and that's why radar isn't just one invention. It's an entire science that keeps evolving. So let's recap what we learned. Radar works like an echo, but with radio waves instead of sound. It measures distance, direction, speed, and even size. And despite being invented in the 1930s, it's still one of the most critical technologies we use every single day. The next time you see a plane in the sky, or check the weather forecast, or hear about air traffic control, you'll know exactly what's happening behind the scenes. And the crazy part? The same principle is now in your car, your phone, and even some doorbells. Radar isn't just military tech anymore. It's everywhere. If you learned something new today, let me know in the comments. And if you want more videos breaking down complex tech in simple ways, you know what to do.